Here Andy's reaching up and grabbing the outboard lines and pulling down on them and actually folding up some of the canopy. This is a maneuver we call big ears. By making the canopy slightly smaller, it increases the descent rate and also increases the forward speed. This allows us to set up landing approaches into tight landing areas more easily. By letting go of the outboard lines, the canopy reinflates by itself, and Andy's just using weight shift and brakes here to line up on the spot, called an A-riser fold. I reach up and pull down on one attachment riser, folding half the wing. The glider, as you can see, is still safely controllable. We practice this maneuver because sometimes in extreme turbulence, the wing can collapse like this, and the pilot must practice it so he knows instinctively how to control the glider and what the correct inputs are to the brake toggles, and what weight shift to use to continue to fly straight. This is another example of big ears, very easy maneuver to do, and also very stable. A good maneuver for setting up landing approaches. Now, I'm not using the brakes here at all. I'm just shifting my weight in the seat, and by shifting my weight, it causes the glider to turn. So there's two ways we can turn. One is by pulling the brakes, and the other is by using weight shift. To reinflate the tips, all we have to do is just let go of the lines we pulled down. Andy Whitehill had a good launch and is going to demonstrate a front horseshoe for us. He's getting set up and flying out so he's got enough altitude and clearance from the terrain. The front horseshoe loses altitude at a much more rapid rate. Andy's flying a Wills Wing 125. This is the largest size beginning intermediate canopy that we have. Here he pulls down on the lines. The canopy, the two wings fly forward and actually meet, and you notice his sink rate goes up pretty dramatically. We do front horseshoes to lose altitude at a more rapid rate in the case that we're getting sucked up into a cloud or the lift is too strong and we want to get down. Simply by collapsing the front of the canopy in the center, you see the two wings fly forward and the sink rate goes up. Andy exits the maneuver simply by pulling on the brakes. Now we're going to watch Mike Meyer, Wills Wing test engineer, demonstrate a full stall. Mike's trying to gain a little altitude because the full stall, as you shall see, loses altitude at a very rapid rate. The purpose of a full stall is to get out of an unrecoverable spin. Sometimes during a wing collapse, you get entangled. The maneuver of last resort is to go into a full stall. This maneuver you're about to see, Mike is going to enter intentionally. You'll see the trailing edge come down slowly, further and further, and a stall. Mike swings out in front of the canopy, and the canopy is fully collapsed. As it starts to spiral, Mike's going to let his hands up to institute the recovery. The canopy actually flies backwards for a moment, then surges forward. Mike uses the brakes aggressively to stop the surge and then recovers. After Mike's flight, we had a chance to talk with him about what the maneuver felt like.
Well, the institution of the stall was fairly normal, except my feet came up farther over my head than I expected. But by this time, the stall is in a normal, stable state of descent. But I did pick up some rotation, so with not a lot of altitude to spare, I wanted to go for a gentle recovery. Went a little too gentle on releasing the brakes, and the canopy stayed in a stall and actually flew backwards. That made the resulting forward surge on final recovery also a little more severe than I intended. But with a heavy application of brakes, we were able to stop that and recover.
Let's listen to Mike Meyer take us for a flight off Telluride's famous Gold Hill launch.
At 12,000 feet above sea level, Gold Hill is one of the most scenic launch sites anywhere in the world. Just off launch here with a camera on the glider, I'm working the lift right out in front of launch to try to gain altitude. Looking forward from the glider, we've got a beautiful view of the Telluride Valley, and the town of Telluride is located just over that ridge in front of us. Looking back up at the canopy, we can see how some of the maneuvers we've talked about are actually performed. Reaching up to grab the outboard 3 lines on the front riser on each side and pulling down folds in the wingtips in a maneuver we call big ears. This makes the canopy smaller, increases the descent rate and the forward speed. Releasing the lines causes the canopy to reinflate automatically by itself. If we grab the inboard 3 lines on the front riser, instead of big ears, we get the front horseshoe, where both wingtips fly forwards and meet in the center in front of the canopy. This reduces the size of the canopy to only about 1/3 its normal size and produces a greatly increased sink rate. Holding down on one brake causes a spiral turn, which some paraglider pilots refer to as a positive spin. In the view from the glider of the positive spin, we can see the clouds going by up above.
Taking air. We always wear helmets when we fly. Rob's going to demonstrate a spin for us. Gets the glider very slow, lets one hand up, and the glider rotates. In recovering from the spin, Rob pulled a little bit too much brake and actually spun in the other direction. Now he'll pull down both brakes sharply and recover from this spin, and the glider flies out. Rob's flying a Wilswing AT-123. Here you can see how he's pulled down the trailing edge. This causes the wing to stall and spin around its vertical axis. Rob's looking up at the canopy during the recovery. A little bit too much brake and the canopy begins to spin the other way. Very tricky maneuver. Spins and full stalls are the 2 most dangerous maneuvers in paragliders. These are always practiced the first time at a high altitude using a life preserver over a lake under the eye of an experienced instructor and under radio supervision.
Of course, a canopy wing is not a stable flying object. Our test pilot mounted a camera on his feet to demonstrate how a canopy reacts in extreme situations. The canopy can be brought into a controlled stall condition by strongly yanking both control lines downwards. Air spills out of the canopy, deforming the profile, causing severe altitude loss. The pilot only has a fluttering piece of material above him. A safe canopy design will immediately open and build up its profile again after a maneuver like this. The spiral dive is an extreme maneuver where the canopy remains stable but quickly loses altitude. This method can increase the sink rate to 18 meters per second and is used for extremely fast descents. One 360-degree turn can lose up to as much as 60 meters of height, so it is utterly essential to have no less than 100 meters to the ground left when executing this maneuver.